Dear participants and respected speaker, a very warm good morning to one and all. I, Varlin Betty Cruz, Assistant Professor, Department of ECE, delighted to welcome you all on behalf of Gates Institute of Technology for the 4th day Faculty Development Program on Advanced Technologies and Challenges in Electronics and Communication Engineering, organized by Department of ECE, Gates Institute of Technology, Kutti. And now I request Mrs. S. Anis Fatima Madam to introduce the day 4 speaker.
Good morning to all. I am Anis Fatima, Assistant Professor, Department of ECE, and I am privileged to welcome the day 4 speaker, Mr. Ratnadeep Pingale, Executive Head, Indian Engineering Division, Varroc Lighting Systems. Sir is an electronics graduate from Pune University. Sir has in-depth experience of 27 years in designing and development of electronics products for market segments like industrial, energy and utility, automotive, instrumentation, highway and automation. Sir has worked with OEMs as well as engineering services organizations in different capacities, right from an individual contributor to global delivery head. And now, Sir is currently working with automotive exterior lighting type 1 in Pune location as engineering head. Sir supports both domestic and global customers for product development in compliance with global automotive standard. Sir, we are glad to welcome you, sir. Now you can start the session, sir. Thank you all.
Yeah. Thank you for that wonderful introduction. So I'll just share my screen. Okay, just let me know when you see the screen.
Your screen is visible, sir.
Yeah. Okay. So good morning to you all. So I'm already been introduced by the lady, and I'm really thankful for that. And actually, when the college first approached me, like they would like to have a session on the industry, okay, the industrial segment, okay, mainly from what are the opportunities available and how for an electronics engineer into the today's situation. And I think this is very an apt question and the need which one should be looking at. Okay, the reason is when I did my graduation some 27 years back, to be frank, I never had a clue what exactly I should be doing in my life. Okay, I never had people around me who are known for this segment. Okay, my family background is completely different. It is absolutely non-technology thing. So this was a big question in front of me. Okay, I've done my graduation, I've done my engineering, but what exactly I'm going to do for next 30, 40 years in my life? Okay. And if you don't get the answer at the right time, I think that affects your career a lot. Okay. Okay. First thing is, okay, so from that point of view, I've made these few slides. It is not a very big presentation. I have around 2 hours available, but I may not be sure whether I will be, the presentation may go full. I just have some 14, 15 slides, which I will share with you. Now, whatever I'm going to say, it is not something which will give you a right away answers. Okay, so it is not something I will tell you which organization, which sector, which company, which location. Nothing is going to be the upside. Okay, from engineering point of view and the education point of view, I think the excellent professors at Gage Institute who have already taken care of the knowledge part of it. What I am going to share with you is my experience and how should one approach in a professional career and based on your educational background. So that's what I'm going to really focus on. And in this 14, 15 slides that I prepared, I will let you know which are the market segments, which are the areas where electronics is applied, it is used, and and how exactly you should look at any application areas. Okay, and how the electronics that you have learned, okay, the education, the academics, how it is linked with the market that we have available or the industry available. Okay, so today everything is like people are talking about software. So there could be, I've seen many people, they have done mechanical engineering, but they jump into software. Okay, actually all streams are equally good if you really understand how it is linked with the outside market. Okay, how it is really utilized for the benefit of the human mankind, anything. Okay, okay, so that's what I want to say. I hope I am audible and pretty clear because I have a very husky and low voice. So if at all there is anything, please let me know if I am not audible.
Sir, as of now, no issues, sir. Your voice is audible. If there is any issue, we'll let you know.
Sure, sure. Thanks a lot. Thanks a lot. Okay. So let me quickly let us speak into the agenda that we have. Just 4 agendas that we have today. One is we will cover the market segments. I think my screen is not changing, so let me change it. Yeah. So we'll talk about the market segments. Market segment is something which is linked with, we just categorize overall industry into some market segments. Okay, for example, we talk about automotive as a market segment, aerospace is an automotive segment, is in the market segment. For example, medical could be one, and so on. So we'll talk about which are the different market segment available where electronics is being used prominently. Okay, so that's what we are going to cover in market segments. Then we will move to more specific into industry. Okay, so and for that, let us start with understanding what exactly is Industry 4 about. So this is a buzzword nowadays for last, I think, 10 years or so. You will see this buzzword in the industry, like Industry 4, Industry 4.0, 4.0. So what exactly does it mean? And it could also be possible that you would have never heard of what is Industry 3.0, 2.0, and 1.0. So let us also understand that. So this is nothing but the journey of the industry from 1 to 4. Okay, now we are looking at something 5. So that would come in future. But let us understand what this 4 is. This will give you much idea about how the industry has progressed for past maybe 2 centuries or so. Okay. Then we will come to more specific into applications. So applications is nothing but it is applications of electronics in certain areas. Okay, that's what we are going to cover in short. Okay. After that, in the end, we are going to talk about how really we connect the electronics knowledge that we have acquired during our academics. It could be graduation, post-graduation, but how do we really link to what work is getting done in this application or in the industry? Okay, so because the market is huge and we are outside, so this today, if you look at if you look at in the media or social media, there is always a lot of leadership, industry leadership. We'll talk about. We get good students from the college, but they don't have exposure to what the industry is doing. They have pretty knowledge about what exactly the industry is doing, what is the industry expecting from them, and how people needs to be ready for that. Okay, so I will talk about that part in this last segment over there, which is in key aspects. Okay, and then maybe I will also talk about some electronics specific stuff which would be of your interest. Okay, and then if at all there is any Q&A session, I will be open for that also. I think there is some. Yeah. So talking about market segments, okay, the first one and the big one is the medical science. So medical science initially, if you look at it started as a very exclusive of electronics. But as electronics started progressing since, I think it would be towards 1970s and 50s and beyond that, with, with the progress of electronics. Okay, so just to give you how we can measure that is maybe somewhere around 60s and 70s, we were having bit slice processors. So it could be 1 bit, 2 bit processor, or 4 bit. It was nibble that time. And today we are talking about 64-bit microprocessors. So that's a change. Today we are talking about 4 nanometer wafer. Okay, so that's advancement in electronics that has happened. Okay, and with that advancement in electronics, every segment, market segment, has tried to adopt or tried to benefit out of this journey of electronics. Okay, so whether when we talk about medical science, whether it is diagnostics of any diseases, so over there it is a lot of help comes from electronics. When we say diagnostic, let us say about sugar, diabetes. Okay, so whatever gadgets are available nowadays, they are electronics. Okay, that's how they're made. Health monitoring, so it could be a BP machine. It is electronics based. So earlier it used to be that mercury based. Okay, so that's outdated now. So even for temperature, we use a digital probe. Okay, so everything which was there conventionally is getting replaced by electronics or we call it as a smart devices. So smart devices for diagnostics, smart devices for monitoring of your health, and this is going to be big future in electronics for health science. As I said, it is really going to change the way in which we look at health or personal health. That's going to change. So if anybody is interested in having electronics application in medical segment, I think that is the best career. If you have interest, everything boils down to what is your passion in life. So if you really have passion to, first of all, you are anyway electronics graduate, but if you have passion to build products, okay, I have been doing it for past 27 years, and I'm still not tired of developing product for different segments, because that's what makes me happy. So that is the crux actually. If you really are happy in doing something using electronics to benefit something else or to contribute a segment, that's what is going to be the career journey, and that will help you for a longer journey. Surgery assistance. This is another thing, and this is going to remove the bottleneck of the surgery. Here, electronics is very much handy. Okay, so though the application or the usage is in medical, but other market segments will come for the support. We are talking about surgery taking remotely. Okay, so that's one area. Plus, robotics is coming over here very prominently. It has been used because it is more precise. There is no error. Okay, it can do things right properly. Okay. Today we have robots which can even stitch a wound. Okay, so all those things. This is possible only because of the technology development in electronics. Automated medication system. This is something very unique. Okay, so if you look at this, like what exactly it is, I can give an example. Diabetes is a very classic example of this. So okay, something out of electronics, I will just say from the interest one. Diabetes has two types, type A and type B, or type 1, type 2. So type 1 is where the body stops making insulin. Okay, and type 2 is something the body is resistant. Okay, so it doesn't take insulin, and that's the reason the blood sugar level goes higher. So in type 1, we have to take the insulin injection whenever we are taking the meal. Okay, based on what is how much amount of carb that we're taking in, and from that proportion we take it. And it is a pain actually. So every time, maybe if you have a meal 3 times a day, 3 times you have to pick yourself with an injection syringe and all those things. But nowadays there are electronics gadgets available which can do this job automatically for you. There are some, they're inside the body, they're injected inside the body, they're placed, they do a small surgery and they put it in your abdomen. a small device, and that lasts for 2-3 years, and it is automated. It is completely internal. So this is the kind of advancement that has been done by in medical science by using electronics technology. Okay, and so if we just look at this, how do we really think to use an electronics into a market segment? If you want to have something working for a long duration, then there are a couple of things that it should suffice. First one is it should consume no power. We should be okay. Second thing is it should be very precise because it is medical. It should be able to precise. If you have to measure something, then we need some sensors. So it goes all around. Okay, so the role has to be thoroughly holistic development in electronics as well as medical science or whatever segment we are talking about. It should be. Okay. Second segment is the transportation. So when I say transportation, it is moving from point A to point B, either through air or on road or on ground. It can be through road or by rail, or through water or in space. Okay. Now, if you look at all these things, it would have not been possible if the segment had not adopted electronics as a means to replace the old mechanical systems. Okay. So, if you look at aerospace, for example, they use a huge amount of electronics. Okay, and in fact, they have the power rail itself is completely different. How it is not the way in which we have it on the ground level. At ground, we have 50 hertz. You go to US, it is 60 hertz AC signal. You go to airplane, it is different. It is 400 hertz. This thing. So based on that market segments, electronics needs to be adopted for that particular application and to achieve some benefits out of it. Okay, and this is where the correlation comes between your education and the target area. Okay. Second thing coming for this road, so automotive is a big segment. So it is automotive, passenger car, commercial car. Maybe I think you can see it over here. Let me pick up the pointer. Yeah. So passenger car, commercial vehicles. Then we have rails. Rails are going under phenomenal changes now. Okay, a lot of electronics and mainly the power electronics. So today we are going to talk about industrial electronics, which is nothing but power electronics. Okay, so this is one. Ships is there on water. Okay, so ships are not the way in which they were running with steam and other things. So whatever the power generation source, it has been replaced by batteries or AC power. And then that power is used to either to propel that particular vehicle, if it is vehicle or ship or plane, anything, it can be anything. That's all. So we need to create some power. We need to generate a power at some source. If you're going to disconnect from the grid, then we need to store it. Okay, so if it is, let us say, automotive, it is not fully connected. It is not permanently connected to the grid. Okay, or it is that is not a power source itself. If it is IC-based engine, IC is industrial combustion. So we use fuel, gasoline fuel, and something like that. That gets converted into energy. That energy is stored in form of electrical. And that electrical energy is used to drive all the electronics available in the vehicle. That's it. So this segment is very huge. So in road, you have passenger car, commercial vehicle, off-highway. So off-highway is we have this JCBs, excavators, harvesters. So all these come into that category, off-highway. So they don't run on the normal road; they're on the field, off the road. And space. So you would have already seen a lot of advancement being done in space. So now you have a lot of even private players into it. Like Tesla is also making automotive vehicles as well as they are into space. This thing also. So these are the segments which you can think of. If you have really passion to work into the segment, even with so electronics background is the best one to be into any of these segments. And electronics gives you that opportunity actually. Okay. I will move to next one. So the next segment we are talking about is the defense sector, the most biggest one. A lot of money is being pumped into it. It is because we don't want to be in harmony with our part, with our this thing. Okay, so because of that, a lot of defense requirements are coming up. Okay, this is nothing but this is a yeah, this is an action of building our supremacy. Okay. So over here also we have transportation, one of the areas which is same as what we saw, but this transportation is different. So we will have vehicles, commercial vehicles, we'll have passenger vehicles, but the requirement are completely different. So the mill standards. So in defense, we develop all whatever we develop, it has to comply with the mill standards. Mill standards are more stringent than the commercial standards. So in the previous slide, the transportation segment that we were talking about, the products are designed to meet the commercial standards for electronics. So there are many standards are there, okay, and for automotive. Um, okay, and but when we talk about the same transportation segment, but for defense market, the requirements are much stringent. Okay, in terms of whether it is electrical noise or whether it is power, uh, any other thing. Okay. So here also we have road vehicles, off-road vehicles. Mainly, most of these are designed to work in off-road only because they are not supposed to work on civilian areas. They should be working on the off-roads. So the build quality is different. The control quality is different. The noise level which is available over there inside the vehicle is pretty high. Okay. And second thing is the communicate. It has to be connected. So that is the last point which I'm talking about. Second one is the weapon system. So weapons which are used for attack as well as defense. Huge amount of electronics is utilized over here. Okay. Okay. So if you talk about, see, this is a missile which you're talking about. Okay. Then these are all this thing. This is the attack segment, artillery, and then we have this defense system. What we see, I think it looks like this S-400 from Russia. Okay. So different segment is a it is using huge amount of electronics. So if any one of you is interested in that kind of market segment, that kind of product line, yes, you can go through. You can go to it. Okay, and it is using electronics is in a huge amount. Okay, and it is going to if you look at most of the systems which are there mechanically, okay, on his journey, they are getting replaced by electronics and mechatronics. So this is where it comes very handy. So electronics and mechatronics are something which are used in all market segments, whether it is medical, transportation, defense, even in communication. Okay. So the last part of defense is communication requirements, both sensing, okay, mainly used for sensing. So sensing could be in various areas. We have this vision-based thing. Then we have for bioweapon, we need to have the gas sensing or air sensing. That's what we call it as. Okay. Then the fourth one is the communication segment, market segment. This is a huge one. I think this was the last revolution, I would say, somewhere around 90s and beginning of 2000. It was a communication era where all these mobile phones and everything was they got developed. Okay, so and we were able to talk with each other at wherever point we are. Okay, so that okay. So this is the communication era which we are living in. It is almost towards the end now. Okay, the form may change, but what is that we talk about in electronics? So it is. So I'm just trying to categorize it based on the medium. Okay, so whether it is a wireless medium or it is a fiber optic or through wires. Okay, and each one of them has different intricacies in how it is getting developed. Okay, so okay, and it is supported by electrons. It is supported by electronic. So if it is wireless thing, okay, the medium is wireless, but we need a transmitter and a receiver, and that is electronics. Okay, and how it has to be designed, that depends on what medium we are using to transfer. For wire, it is different, and the issues are different. For wireless, the issues are different. For wired, the issues are different. For fiber optics, we don't have issues in transmission, but we have issues, some other issues. Okay, for fiber optics, how to receive it, and the wire has to be continuous; it cannot be broken. So all those things are there. Okay, but this is just an overview which I'm going to let you know. So if any words really catches your mind, just note it down. Just try to do some your homework around it. Then you will find a lot of areas, career options into that particular area. So I will just give you an entire gamut of market segments which you can look at for making a successful career. Okay. And then the second one is the physical layer. Physical layer, okay, so it needs some electronic support from outsides, like that is a wired one, so it has a different kind of receivers and transmitter. Same for optics and wireless one. Okay. Okay. Now, whatever is not listed over there, so there is a big segment where we manufacture a lot of things, a lot of products, small products, okay, which we use in our day-to-day life. Okay, but it is not a big industry as such. Okay, so there is, I think there was one more industry which I forgot. Just 1 minute. Yeah. So core industry is nothing but it is still not switched. Okay. Actually, sorry for that. I'm using two screens, so my laptop screen is not getting the sync to the screen which I'm sharing with you. So this is a screen which I share with you, but my laptop screen is different, and they were not in sync. Okay, that's the reason I was trying to put that right. Okay, so here we talk about power, energy, utility as one sector. This is a huge one. Okay, but it has changed since electricity became available for us. Okay, the way in which we run this show today is it is a huge jump in terms of technology, and it is a huge the kind. It has a lot of intricacies actually. So because though we use electricity in day-to-day life 24/7, but we hardly understand what has really gone behind it, making it available for us. Okay, it is a huge network. It starts with power generation, and then it comes to transmission, and then the distribution. So I think we'll talk about that later. But if you talk about this market segment, what exactly it is made of? It is a smart grid system. So the reason I'm telling it smart grid is substation to substation, there is a communication. And if you have some understanding about power generation as such, it works on demand, maximum demand. Okay, it should have an average demand, and then there is a maximum demand. Okay, so we can switch off our light any given point of time. So we can switch off industries any given point of time. But generation cannot behave like that. It works on average demand and maximum demand, and it keeps on once it has that the data with us, it is automatically communicated which segment to put on, push off, all those things. It's a huge network of power lines, which is supported by the control lines. Okay, so that's nothing but it is a smart grid system. So okay, even in generation, okay, so generation conventionally it was done very. It was a crude metal, so crude way. So in most of the countries we were using thermal power generation. So then some countries switched to the nuclear one, and now is there we are talking about green. So we are talking about how we can make use of the existing energy and convert it into the energy which is utilized by us. Okay, metering, smart metering. This is very important, and it is the most crucial one. Okay, because metering is nothing. It is not just measuring it. It is somebody is going to pay based on what your product is going to say. So everybody's houses, you will see energy meter at the entrance, and it is just the inlet of your power line. And we have a very small, decent one box lying over there. So sometime maybe if you just look at 10 years back, we used to see one product which was having a ring inside, which was rotating continuously, and that was on the principle of magnetism. Okay. But now that has got replaced, and we find some small electronics box with a blinking LED. Okay, and it is recording the power that you are consuming in your house, and then you have to pay at the end of it. So wherever there are products where the output of the product is going to result into commercial transaction. The product has to be damn steady, excellent in terms of reliability. It should be consistent. Okay. Otherwise, it gives you some other sorts of problem which you cannot handle. So the reliability of the product is extreme. It has to be extremely high, a very high level. Okay. Though the electronics that we use would be of the same type or this thing, but the overall product reliability has to be very high level. It cannot be accepted. Okay. And last one is the controls and the communication, which I was talking about. It's like the generation, it works on average demand and maximum demand, and based on that, it keeps on producing power. And the smart grid will keep on switching the power from which sector, which area we have to give the power, and from where we have to. So that is called as load shedding and all those things. It has to be done in a very smart way and very quick way. So that is available through this. So for communication and the controls. Okay, so I will talk more about it when I come to that segment in detail. And the last one is the consumer electronics. Okay, this is a huge segment which has come. Everybody of us want to enjoy life, live comfortably. A lot of work in our house needs to be done by somebody else. Okay, at our wish. And this segment is really becoming so in business term or in marketing terms, it is also known as FMCG. Okay, fast moving commercial goods. Okay, and there is no this is continuously growing. Okay, and it is growing because of, I think, mainly the second line, I would say. Okay, sound and vision, everybody knows. Okay, so we need to have some iPods or music systems in our house, then very excellent televisions. Now you can look at the television journey that we had seen. We started with the CRT tube, and now we are talking about flat televisions, which are already there. Some years down the line, you will have televisions which can be work like your window panes. Okay, so flexible LEDs, flexible displays, and all this. So that is just around the corner. We are going to see. Okay, it is possible because the kind of revolutions that we are doing in the electronics. Okay, the more we understand about how exactly we can the electronics work, we understand materials, how we understand to make use of semiconductors, and we also understand properties of other metals that are there in the periodic table. We can arrive at different applications around it. Okay. The thing which I was talking about is the booming in consumer electronics is the personal care and grooming. So the machines that you use for grooming yourself. Okay, I think we have around 6-7 billion population in this world. Just think about even if say 10% of them want to have a grooming equipment, what is the market size you can think of? Okay, so whether it is doing your morning stuff. Okay, in Corona, a lot of people brought the hairdressing. Okay, it is nothing but a grooming. It is electronics. Okay, it works on either it is an electric motor with some controls behind, whether it is based on magnetics, many other things. Okay, and then okay, so this industry is going very fast. Then also we have this humidifier, then appliances are there, household appliances are there, television, fridge, washing machine. Everything is moving from conventional only mechanical electrical to electronics. Okay, and all these things are going to get enabled by enabled with communication capability. Okay, and that's the change that's going to happen. So we'll talk about that in next slide, what exactly it is in Industry 4.0. Okay. Then comfort and lifestyle. So comfort is okay. You talk about fans. Now we get fans which are remote control fans. We get ACs, air conditioners. Okay, we get intelligent air conditioners. We can switch on the air conditioner from your office. Okay, now. Okay. So all these things it is linked with us, with people, and how we can get benefited out of those electronics usage and make it more intelligent. Okay. Nowadays, most of the people they are working away from their family, and still they need to take care of their house. So the smart devices, smart consumer electronics product, okay, that is going to come handy in this situation. Yeah. Okay. And last one is the home security. Okay, it's very important. So nowadays, instead of using the old conventional lock as a security measure, we are talking about cameras inside. We are talking about there is a whole security system which can be installed in a house, and which will give you update of your wherever you are, whether you are working on office, whether you are on the transit. There is an alert which comes to you. Okay, so all those things, maybe we may not find locks in future. You will get some console where you can, maybe if you go to hotels, you'll find some smart cards we use over there. So this is nothing but this is adoption of electronics in whatever we do day to day life. Okay, that's about consumer electronics. The stuff that we do regularly in our day to day life, how we can make use of electronics to make it more smoother, safer, and comfortable, and at our own schedule. Okay, so even if we are not in office, even if we are from office, we are going to home and we want to do certain things. The appliances, the smart appliances that are going to come, that are going to help you. So I just came across something like I think I don't remember the name of the company, but we are going to get some smart appliances which will, or it is in robots. I think they will help you to cook your meal. Okay. So things are the applications are going to that level, and this is really going to make your life much more, I would say, peaceful, easier. So you can spend more time in enjoying yourself, do things that you want to do that makes you happy. Okay, so that happened. Yeah, and the last one in my list is core industry manufacturing. So this is nothing but there are a lot of items around you which somebody has to manufacture in a large quantity. Okay, so simple things could be, let's take example, paper industry. Okay, there has to be a plant somewhere which will help you to make that product. Pencils, pen, staplers, pins, anything. Maybe your watches are there, your water bottles are there, bags are there, anything. You just look around you. You have a lot of things which somebody has to manufacture in a lot of quantity. And this is nothing but it is an industry which only do manufacturing. So they don't do a lot of other works, but it is only how to manufacture uh, a product or an item with a very high product efficiency, manufacturing efficiency. That's it. Okay, so it could be they would be using some automates, another thing. I think I don't have that video. Maybe I'll have to check with that. So, okay, so this industry is it's huge, and what all does it make use of? So if you want to have an if it is a manufacturing setup, then you need to have controls, which is nothing but it is electronics. It is electronics based. You need to have monitoring on it, and then there is automation, which helps you to do both the above. Okay, it helps you to do automation will help you to improve the productivity. Okay, okay, so these are the things that comes into core manufacturing, and the application can be anything. So what exactly you are manufacturing, it can be anything. So if you just change few setups here and there, I think the entire output changes. Okay, So let's talk about this Industry 4.0. I won't go in details. I will just give you some glimpse of it. So at least you will have this in the back of your mind. How, uh, what exactly is this Industry 4.0? Yeah. So if you look at this side, no, you will see this. Okay, the time. So it started somewhere around. It is just a date put. It is nothing like it. It is something which is retro fixed, I would say. So somewhere around 17th century, end of 17th century. So we can say that was an industry 1.0. So this was 100% mechanical, using now for any industry, power is the most important thing. Okay, so at that time it was everything was around steam. So you boil the water, you generate steam, you compress it, and you get an energy which you can use it. So that was a era which lasted for around 90 years or so. Okay, and everything was driven by steam. Industry 2.0 was which was around the end of 18th century, we can say. So that was so when the electricity was available and we can make use of electricity for getting our job done. Okay, so we had these electric power assembly lines, and then the mass production was made using electricity. Another 90 years towards the end of 19th century or 20th century, you can say. Okay, so around this time, it was Industry 3, 1970, that time frame around. And this was a era where automation kicked up. Okay, now the main reason for automation to pick up was the market demand was very high. And if we really want to do something conventionally or manufacture something conventionally, then we will not be able to meet the market demand. Okay, so you would have heard some of your parents and grandparents they were talking about. If you book a vehicle, it took at least 2, 3, 4 years for you to get that. Okay, that was because the market demand was high, but the production was very low. Okay. There was no means for them to improve that. And this is where this automation thing started. Okay, if you automate certain process, it will give you two things. It will give you speed of manufacturing, and second thing is it will give you consistency on whatever you manufacture. So the human part you remove, and that's how you can speed up. So that's what started in Industry 3.0. And today we are into this Industry 4.0, which I think they started somewhere around, I think 10 years back or so, if I'm not wrong, somewhere around that time frame. And and this is mainly with so why is it? We are talking about cyber physics system, Internet of Things, and smart technologies. Okay, so Industry 4.0 is something which is centered around communication. Okay, so communication is like I would say you have a lot of products, a lot of um, systems which are already there, but they were dumb system. Okay, there was something like SCADA systems came into existence in Industry 3.0 only. So it was more of a computer-based system, so which can have a data acquisition and control dashboards and all those things. But if you are in a system where you already have a lot of dumb products or dumb systems, when I say dumb, it means they are unable to communicate. Okay, so for example, you have a lot of escalators maybe in a mall. This is just a random example. I don't know. Okay, so if the escalator is not talking to, or it is not really communicating the status to the central system, then it is completely disconnected. Okay, and you don't know where the action has to be taken. In order to improve whatever activity you're doing or whatever scenario or situation you're trying to manage. So one thing is very much important is data, create a data, which is generated data, transmit that data, which is communicated data, which obviously has to be to some central console, which is from where it is getting monitored and controlled. Okay, so Industry 4 is mainly around that. Okay, and that also, and what is the thing that you do? So what are the pillars? So the first pillar is cybersecurity. The second one is if you have a lot of data, then it has to go to cloud for computing. Now, cloud is something which is in recent technology it has come. So, but now this industry 4 is making use of that mobile technology. Okay. Then machine to machine communication. This is on the production floor. Each and every machine they talk to each other. Okay. So, for example, there are two stations. Okay, which do two different operations. Okay. So if they are not talking to each other, they won't know what is the status of the previous machine, and when I have to take over the product from the previous machine to to himself. Okay. So in human, we actually do it very without even realizing like what is the importance of uh, talking to each other. Okay, on a station. Okay, but when we have dumb system, we really which do not have any ears and eyes. So for them, it becomes very difficult, and this is where the clumsiness has to be removed by machine-to-machine talking. This is enabled by using electronics. Okay, so on shop floor, you will have a lot of protocols are there. So these in older days, it was mainly a wired one. Nowadays, it is becoming the wireless one, okay, and so on. The third one is 3D printing, advanced robotics. So this is another a very technology pillar for Industry 4.0. This is big data and analytics. So data is getting generated. So whatever would be the station or the place or where we are actually doing this activity, a lot of data has to get created, and that data needs to be pushed to cloud. Okay, it can be pushed to cloud, it can be pushed to a central console or anything. Okay, and then it gets processed and it gets back. So this is one of the offshoot of it. Okay, so this is one of the important pillar of it. Internet of thing is nothing but it talks about any dumb system, you enable it with communication. So it can be wired, it can be wireless, anything based on whatever is possible for that. So you have a staircase, make it intelligent, put an small electronics gadget on top of it. You identify the status, what are applicable for that staircase, some kind of escalators, and then you communicate to the central system. So that itself, and we have a lot of installation already there in the market, okay, which are already there out. Okay, so you have to make them, you have to make them talk to each other. It could be some molding machines. Okay, they are also hooked up to internet now. If we are talking about smart grid, there also earlier there was no connectivity between each stations. Now that they have enabled that also. So Internet of Things is making the systems, the product, which today are unable to communicate their status to the adjacent environment, adjacent systems, or to the center console. So this IoT is going to enable them with that particular capability. And obviously, there's electronics which will enable, which will help that to happen. RFID, another thing, this is used predominantly in, I think it is in warehouse, another thing. Warehouse management is a huge area, by the way. Okay. And the way in which we are shipping materials, just to have a look at this online shopping, this thing, portals, whether it is Amazon or Flipkart or many other. Okay, the kind of uh, sophisticated warehouse they have, okay, and how they're able to manage maybe lakhs of uh, purchase requests every day, and it is getting shipped. So in some cases, you order in the morning, you get it in the evening. So there is a lot of technology backbone which is behind it to make that happen. Okay, so the moment you experience any such kind of this thing, okay, then immediately you start thinking, what are the things that has gone behind it, which has make it happen, and then you will realize there is a lot of electronics which goes inside it. Okay, that helps you. Okay, and then it is just speed. And I was talking about getting a two-wheeler after 4 years. It was because of the inability of the production floor to work to throw out those many vehicles per year. The moment automation came inside, that shot up. Okay, and then we were able to have all this. Today, we are talking, the market size is increasing. We are just not talking about one city, one state, a country. We are talking about global. So today, the definition of market has changed. And because of that, I would say the requirement of the industry, the way in which it has to operate, that also has changed. Okay, today we are sitting in Pune. I'm sitting in Pune. You guys are sitting in Hyderabad. Definitely, there's a lot of industry in Hyderabad, but they are not just catering to requirement in Hyderabad or in south of India. They're catering to requirements all over the world. Okay, and that's what makes the difference. Okay, so our industry needs to be geared up, prepared for that kind of expectations. Okay, China is the best example for that. Okay, so whatever we do, maybe we hate it or on any this thing, that's fine. But that is the best thing that they have done. They have only revolutionized the industrialization. Okay, today they can produce the best product at highest volume at the cheapest cost. Cheapest mean it is efficiency, actually, production efficiency. That's what make it cheap. Okay, it is not by in terms of quality. At the end quality, whatever you expect, that's how you get it. But it is something that we need to implement, adopt in India also. Okay, and it is a huge area. If you just start getting into it, you will understand what is the size of this industry that we're talking about. This is something new, cognitive computation. Okay, so this is nothing but something which is linked with the human behavior. Okay, so this is so you would see a lot of robotics and maybe in the reception area you will find these automates and all those things. So that's the direction in which the things are moving now. So it is not just systematic, but it has to be some cognitive computation. So what would be the human behavior if you are responding to certain things? Okay, so that's something which is opening up nowadays in industry 4.0. Okay. We'll switch on to the next slide. So let me talk about some applications. So I'll just stick to so the market segment I was talking about the entire width which is available today. But now I will be specific into just industry. So let me just see. That's yeah. Okay. So when we talk about this thing, yeah, I think we'll skip this. We'll go to this slide. Okay, so that we don't repeat things. Okay, so I was talking about power generation earlier in market segment. So what are the key parts? I was talking about generation. Then we have the transmission, and then this is control, and then these are the metering devices, how we measure it and display it. Okay, so these are three main components. So smart grid controls and application is which you already talked about. Then there is digital substation and electronic equipment, switchgear and switchgear. Okay, so switchgear is something which is at the lowest end, maybe somewhere over here. It will be over here also. It depends on what size we are talking about. Okay, so I think you can read some numbers over here. So for generation, we are talking about different ways of generating the power. One is coal, this is thermal that we're talking about, natural gas. Okay, the nuclear power plant, geothermal power plant, hydroelectric, the wind power plant, tidal. This is solar, and this is solar plant. This is concentrated solar plant. So this is something different. So it is still using the solar energy, but what they do is they will divert all the sun rays to the center point, and then this gets hot, and then that's how the energy is generated. Okay, so this is the normal photovoltaic plates that we see. So that's a normal way of doing it. This is a control station of any. This is how it looks for. I think this is for nuclear power plant, if I'm not mistaken. But for others also, it would be something similar, because rest of the device, if you just once, for example, for nuclear power plant, once you have created, you have converted into an electrical form, rest of the mechanism still remains the same. Okay, so this is just over here we are talking about wind energy getting converted into electrical. So once the electrical energy is generated, rest of the system will remain more or less same. Okay, it will have a lot of switch transformers, so, air circuit breakers, and all those things based on capacity. Okay, and this has to be handled by the transmission lines. So we have this 161 kV line, and then as we go down, so this is upstream, this is downstream. This is a substation, we can say. This is a substation that they're talking about, and then this is on the, I think this is LT side. So this is HT, this is LT. And this substation has a control station similar to this. This is for generation, but there will be a similar control station for this, which and they have a special communication protocol which is designed for this. It is the physical layer is same that we have for Ethernet, okay, but they have a different protocol that runs on it. So I think it is known as IEC 61850, I think 850, some 850. So that's a protocol. It is a special protocol which runs on TCP/IP. Okay, but you can prioritize the messages that goes. So the Ethernet actually it is not a real-time protocol. Okay, so you just broadcast and we cannot predict at what time it will reach the destination. But it is the best medium. So they have formed a separate the protocol for industrial application, which is I think the IEC 61850, and this has some requirement on both sides. So also on the software side as well as on the physical layer. So it doesn't use the normal switch that we use for TCP/IP. It has a special switch which has some, we can say, an emergency path for critical messages. So that's how it communicates. The rest of the things, it is as per the TCP/IP protocol, but it is a modified one. And that has helped a substation to talk to each other, and through which all the, whether it is what they call it as ground failure or REF or ELF, all those things, they are tracked through it and it is communicated. Or it is the demand part which I was talking about, the average demand, maximum demand. So all those switching happens over here. Okay, and there will be a series of it. And one of it, there will be a series of it that will be talking to each other, and this will be switching off. So if I want to switch off this station will put off this part, and that's how the demand is managed over across the LT network. So energy meters. Okay, so the kind of, these are really a state of art electronic product. Okay, so because the reliability level is extremely high. As I said in the beginning, when I was talking about power segment, this is something which shows you a reading and somebody has to pay money. So it is a commercial transaction. And this is the one which decides like what should be the commercial transaction. So it gives you a consumption which gets converted into commercial value, and then somebody has to pay that money. So the criticalness is very, very extremely high over there. And that's the reason the kind of electronics technology that goes inside it. There are two parts. One is measuring it. So I was talking about, we see that wheel rotating inside energy meter. Today we don't have. So you can see all these meters. We don't see it. Okay. Because the measurement, the sensor. So earlier it was working, as I said, it was working on magnetic principle. But nowadays it is using something else. So they have current transformers and potential transformers. So and that's how they measure it. And there is accuracy around it. We get accuracy. Okay, I'm just getting slightly deeper. So accuracy, it is called in terms of class. So they have class 1, class 2, class 5, class 0.1, class 0.01. So this is a class. So normally in our houses, we have these meters which are class 1 meters. Class 1 means it is accurate to 1% of whatever you are going to measure. So if you are using some maybe 100 units, it is 1% accurate. So there could be plus minus of 1 unit over there. So that's how it is measured. But when it goes for industrial, where the consumption itself will not be 100 units, but it will be 100,000 units. So even 1% is very high for that. Okay, so over there we use much better meters, which I think we call it as a tri-vector meter. So it is a 3-phase meter. Okay, so in our houses we have single-phase meter, but they are 3-phase meters with a 10 times improved accuracy. and they are class 0.1 meters. In some cases, it may also go to below that. But it is not just saying as class 1 meter. There is a huge difference by designing a class 1 meter and a class 0.1 meter using the electronics. There's a huge difference. Noise levels are different, the environment is different, accuracy has to be consistent, reliability very high. Okay, so these are the areas which really will test your whatever knowledge you have acquired in your college, during your academics. Okay, and that will help you. And it is not something which is I would say it is not something. See, the electronics will remain same. It is still RLC circuit, some semiconductors, and that's it, nothing else. But if you know how to make use of those electronics components to achieve the desired functionality, then it will be, then you will be able to achieve it. If there is a mismatch, then either it will be over-designed or it will be under-designed, and that will not serve the purpose. So this is the crux. Okay, and we will talk about it at the last slide. Okay, so this is the generation part. I think so. We have already spoken about it. So this is the generation. I think this is a control room for a nuclear power plant. So you can just have a look at it, and you will figure out where all electronic has contributed in coming up with this, with such kind of a sophisticated state-of-art control station. Okay, so you have computers, which is nothing but electronics. Then you have software above it. That's a different part. Okay. You will have a lot of, these are switch gears, and these are displays for you. So they will tell you where the fault is, which are the line feeders, how much power is getting consumed, and all those things. I think this one is, I think this is for thermal one. I think this is for this one, natural gas and control one. Slightly less complicated, but it is still complicated one. It is big one. So this is for that. So the parameters still remain same. The only difference is how we convert and arrive at an energy which is transmitted through cables. Before that, there can be anything. It can be solar, it can be wind, it can be gas, it can be coal, it can be nuclear, it can be hydro. So that is just available energy in the form, and then we have to convert. So this is at the generation point. Okay, so once it gets converted, this is fed to the main substation, and where it gets distributed. Let's move forward. So, okay. So when it comes to the industry, how exactly we look at it? Okay, so these are the drives. Okay, these are the industrial drives which we are talking about. Okay, so we just by having a power available. Okay, so that we use a lot of electronics over there in making the power available. I'm talking about, it is not just making it available. It is making it available at your, as per your demand, as per the quality. The quality factor is extremely high. So nowadays, if you look at, so they used to say in some time back, like if you go to US it is 60 hertz. Okay, and you can actually run your clock on that frequency, AC frequency that they have. It is 110 volts, 60 hertz. So in India, we have 230 volts and 50 hertz. So that's the accuracy. And there is a huge dependency. And actually, if you don't maintain that frequency rock steady on the value that you have designed, and it is factor of demand also. It is nothing but it is at the rate of rotation of the generator shaft. Okay, and then if the demand changes and there is a sudden switch, it impacts the frequency. Now in India earlier it used to change. Maybe it can go from 50 to 50.1 to 3. It can also go down 40, maybe 49.5, 8. This thing, but that incurs a lot of losses. If the frequency changes, that incurs a lot of losses. It has a lot of behavior impact on consumption. It also has, okay. So in order to, now today, if you look at the frequency level, hardly changes. It hardly changes. It is rock steady at 50. That is because we have made use of electronics, controls, communication, and that is with the help of that you are able to manage the load very efficiently and effectively. And that helps your generation, the burden which is pushed on the generation back, that get reduced. And because of that, we are able to arrive at a very good power quality. Okay. Now, how we make use of this power? Okay, I think this is IEC which I was talking about. No? This is IEC 61850. Let me switch like this. I'm using the screen. Okay, so this is IEC 61850 backbone. This is a communication backbone. So this is in substation area. It is power distribution you have. And these are the electronic stuff that is getting used over here. Okay, there will be a lot of drives will be there, switch gears will be there. This is MV switch gear, this is MV drive. So these are the drives, how they look at now. You look at all these things. This is all electronics. It is all electronic semiconductors. If you have, I think you would have already learned this. The power devices that you have, MOSFETs, I-gates, and all those things. So they are okay. So they are over. They are being utilized over here. Okay, so not over here, but in this drives. In these drives which are talking about. These are drives. Okay, these are drives. Okay. Then when it comes to LV side, okay, so there we have all switchgear which are low voltage switchgear, low voltage like 415 and the thing. So you have drives which are driving the motors. LV products we have, the remote IOs. So these are meant for monitoring and controlling. So there will be a big console which is where this data goes. And for this, they are using a Profinet or Profibus as a communication backbone. So this is not directly connected. There is a converter over here in between. So you can convert from 61850 network to this thing. So there will be a converter. And after that, there will be a field bus or field network. So this is nothing but the end instrumentation that you do. So this picture that you see over here, it is for the process control setup. Okay. So the motors that you see, they're slightly different. They're more compact, and it has a lot of inbuilt electronics inside it. Okay, so particularly not the motors that we use for pumping water and all those things, but the one which is used for sewage, petrochemicals, and other things. Those machines are they are completely different. Okay, the principle still remains same, but the difference comes in how you drive it. Okay. Then let's talk about application area, which is robotics, mechatronics, and automation. And this is where I think today we are very extensively working on to making this, and definitely this is going to lead us to industry maybe 5.0 future, so more matured stage of this. So if you just try to build an analogy around what exactly it is, so let us look at this. What is mechatronics? It is mechanical and electronics. Okay, even if you now you have electronics. Now, what is electronics? I think electronics is also it is electron and mechanics. So electron is okay, movement of electrons. Okay, and mechanics is movement. Okay, so the movement of electrons it could be within the semiconductor. That's how we say it is electronics, and then that further we again couple it with mechanical stuff for movement and other thing, which is mechatronics. So we have control systems. So it is controls, electronics, mechanical, and computation. Okay, so these are the main four spheres, and the cross section of all those four spheres is we can classify it as a mechatronics area. Okay. So rest of the things you can just look at it. Just have a look at this arm. So this structure is provided by the mechanical and CAD. That's how it is. The control system is the movement of this arm is controlled by the control system and software computation. And okay, now how we are controlling that? It is enabled by electronics. So this is your the discrete components, active and passive components that you're going to use in order to enable it to control this arm. Okay. So just try to try to bring in an analogy between to understand a human being. So now, again, I will take the example of which I was talking about, the core industry, the manufacturing industry. The problem statement over there was the production quantity of the thing, it was very low. And that's the reason we adopted automation, and we were able to produce products at a faster rate. And then we were able to fulfill the market demand. Okay. So that was one part of it. Okay. Beyond that, there are certain things which needs to be, and the automation was very, it was, I won't say it was taking any feedback as such, but it was more of an open loop thing. Okay. To some areas it was feedback was taken, but it was very localized. Okay. But the way in which a human being works, it is completely different. Okay, so that's the reason in some places it was still a person was required to do those particular tasks. So, and this is where this mechatronics and robotics, um, a need was identified. Okay, now whatever you see over here is nothing but it is the same human being. So if you look at a human being, what are the things that we have? So there's an RF communication, so which we can, so this is linked with this audio. So we have audio sensors, we have nose, we can smell. So this is nothing but your gas sensors, or in a simple word, we can say it is electronic nose. Okay, but it is a gas sensors, which we have eyes, which gives us, it is focus plus it gives you a visual thing. It is both the things are there. So it is sight, camera, and then you focus. It is we can decide where we have to focus on, because the frame will be much bigger. But then within that frame, where we have to actually focus. So one is vision, and then one is focusing within the available picture, where we have to really concentrate and focus on or observe on. That is another thing. So that is control. We have mouth, so where we can taste, so which is similar to a humidity sensor. Okay. Apart from this, there are many other sensors in this segment. So this is just one example. We can also figure out the chemical sensing. It can also be done. Then we have mouth is also enabled as a speech, which is the communication part of it. So, so this is the speaker, the audio speaker. It's nothing but it is just it is a wireless communication, you can say, but in audible range. So this is RF, so it is radio frequency. So this is slightly higher. So I think the band starts. This is ISM band communication. I think we are talking about. RF. And there is so there are bands in communication. I'm not sure whether you have learned this in college. So there are different bands, frequency bands, which are allotted for particular purpose. So whatever we speak, we can hear with our ears. That is audible band, which is 20 hertz to 20 kilohertz. Above that, AM band starts, which is used for radio communication and all those things. And then above that, it is ISM band now, radio frequency band, which is typically used for industrial communication. Okay. And we go above, then we have this 2.4 gigahertz, which is again an open band, which is used for remote controls and all those things. Now again, there is one more which has come out, 5.2 or 1.1. So, and when we have this communication on mobile communication, we have to buy those bands. So every service provider for communication, they buy. So it is separated out on which band you are operating. Okay. So this is. Then we have pressure sensors throughout our body. So this is nothing but this is the same as the pressure sensors that we use. So pressure sensors are there. Then there is touch and feel. So this is being very prominently used in our mobile phones. In automotive, it is used. Okay, so it lets you know. So earlier, this haptic was achieved by the we had these tactile switches, if I'm not okay. So I'm not sure whether you know that. Tactile is nothing but it gives you a feedback. So if you're looking somewhere else and you're pressing something, so how do we come to know that actually that action has taken place? So there is to be a small dome, triangular dome, which is below the front membrane, which gives that tactile feel. Okay, so nowadays that is being achieved by haptics, what we call it as. So it is nothing but it is a vibration kind of a thing which they give. So actually the key is not giving that haptic. It is the entire screen that vibrates and it gives you an haptic feedback. I suppose. We have some fluids, so which is this pneumatics and other thing that we call it as oil this thing. So that is over here. Then we have audio, or we can hear the audio band. Okay. So this again can be have a different categories based on which frequency you are talking about. Okay, because everything has to be tuned to that particular frequency. So if it is an audible range, it is we have microphones and other things. Like I'm talking to you, I'm using the laptop microphone, and that is getting converted into an electrical signal. It is transferred over TCP/IP, and then you are able to hear it through your speaker. Okay. So that's nothing but it is from microphones to the speaker. Okay. Then body balance thing. So this is something new which is coming up. It was not there in the previous automation that we were talking about. And then the site. Okay. So now if we are able to have all these sensors available and we can put them together to do a functionality which a human being can do, that's nothing but this one. Okay, the advantage that we get over here is because of this fluids and power of this thing, the amount of power that it can handle. Maybe as a human being, we may not be able to lift anything which is more than maybe 100 kgs or 200 kgs based on what kind of person you are. But that becomes a cakewalk when we have equipment like this. Okay, so and this is being adopted at a very large scale into the industries where the production quantity has to be very high. So whether it is automotive, it is very highly it is used because the amount of volume that everyone is producing. If we just look at Maruti, if we just put all those things together, because the manufacturing line is the same. Okay, or it could be separate for separate products based on what is the productivity, efficiency of that line. So based on that, they will do it. So this is just a very a limited form of the human being, okay, which can handle a lot of power, precision, accuracy, and throughput is very high. To achieve that, they will have a sequence of machines, and they're talking to each other. Okay, so because their arms will never get tangled to each other, okay, because they're talking to each other. Where I am, and that's how it works. So it is similar to human beings. So we are talking in a crowd. Okay, so even maybe occasionally we may still bang each other, but if you are really in a tight position, but if you're really cautious and it is really there is a space, I don't think it is possible for us to bang anybody. Okay, we don't bang on each other. So that's because we think, we see, we hear, we sense everything, and we make use of all these sensors which are available on our body to control our movement. Okay. And the same thing is with adapter. Now these are stationary ones. The stations don't move, but only the arm moves. Okay. So this is the kind of robotics that we are talking about to be very largely adopted by industry to make use of it. Now, this is for material movement manufacturing. So the industry which I was talking about earlier, manufacturing industry, core industry. So this is typically that kind of a thing. So over here, I just want to highlight on what are the electronic products or systems or mechanism which is used over here in order to help you to produce that kind of production quantity. Okay. Because without communication, it is not possible. Okay, so each and every station, the data has to get created. It has to get communicated to the central system, and then that's how we know where we can improve it. Okay, okay. So it is similar to what I'm not sure, but it is a project management term. So if you are used to it, so they have this critical path. So critical path is the shortest path. Okay. So, and if at all there is something which is really making, that becomes the weakest link in terms of speed. So they have to arrive at an alternate mechanism where they can eliminate that. So that, in order to take that decision, this MES system will help you. Okay. So MES is nothing but as manufacturing execution system. Okay. Okay, so we have all this system, they talk to each other, and then it goes into MES system, which helps you with the takt time of each and every station. Okay, so here we make use of a lot of sensors. So in MES system, mainly the sensors are position sensors, which are digital or linear. Okay, and that information is converted, it is captured by MES system, and it will tell you how, in real time, how your production level is getting moved. And this can be implemented for any kind of product, whether it is the smallest one, or it is just or it can be to the most complex one. So everything is getting controlled over here. That's how we can do it. So just to give you how it actually, what are the different layers of it. So this is a shop floor. Then when we go on top, we have this PLCs and SPCs. So this is the control level. This is production level. This is control level. Now over here, these are using programmable logic controllers. Okay, so these are just digital I/O and some analog I/Os are given over here. This is a supervision level. So SCADA is nothing but it takes data from multiple units or PLCs, and then it gives a supervisory control. Okay. Then here is the management level. So the decisions and everything are taken over here, and then they are sent back. Okay, and this, and afterwards it goes to ERP. So ERP is enterprise resource plan, and without this nowadays there is we cannot do with this. It has to be there. Because if you look at an automotive industry, for example, it has, I don't know, maybe 1,500 or more than that, 2,000 different components to be sourced on time, assembled in a vehicle, and the vehicle has to go out. Okay, and the Japanese are excellent in that. Okay, so you cannot pile up all these materials when the production level is high. If you're talking about a person is making maybe 10 vehicles or 100 vehicles in a month, and the person who is making maybe 100,000 vehicles a month, the situation is different, which both of them will have to face. It is absolutely different. And that is the reason whenever the quantity goes high, the complexity of handling that similar thing, it is 10 times or 100 times more difficult. Okay. So quantity plays a big differentiation factor. So maybe same thing, maybe you can also apply it to our population. The things which can be implemented very easily in European countries, it is very easy because it doesn't have that much amount of the population is less. But if you want to implement that, it is much easier. But if you just want to adopt it in India, it is difficult because the users are different. Users are very high numbers. Okay. And this is where a lot of decisions went wrong. And then, for example, let us talk about this power industry. We adopted our power network based on UK. We just blindly adopted it. Actually, the size of our country is completely different than what UK is. So for UK, maybe that could have been the best decision or best solution. But when that same solution, if we try to implement in a bigger country like us, it may not serve the purpose. And this is where the losses go high. And that's the reason we have to jack up the voltage and then bring it down and all those things. Okay, so it has a lot of implications just by changing the number. Okay, and it is a major factor. Okay, now this is another segment. I think this is pretty new, not okay, building automation. So building automation is anything you talk about mall, shopping malls, then cinema halls, convention centers, and other thing. But all these nowadays are there centrally monitored. Okay, so this is a very big sector for electronics also. So you need room temperature sensors and all those things. Let me just see if I have. I think it is over here. So we have AHUs, chillers, FCUs, boilers, pumps, VFDs. VFDs is nothing but a variable frequency drive, which you have seen in the previous slides. Okay, those tall ones, no? They were frequency drives. So the speed of the motor changes with the frequency. That's it. CCTVs, water meters, energy meters, elevators, escalators, EMS system, and FAS. And this is how it is controlled. So he is the operator. He gets all the data over here. He sees it, and he manages. And this is where I was talking about. If you look at IoT and other things, I was talking about how we can make elevator start talking to the system. The moment it starts talking, he knows what is the status of this. If it is going to go under maintenance, then he can schedule that maintenance. If it is under breakdown, he can book people for help, he can block it, all those things. And this helps in making the user's life much more peaceful. Okay, so now in building automation, if you see, I think I would like to, then the communication protocol that you see, so we have smart outlets, energy management system is there, you have smart locks, as we talked about, there's a lot of electronics inside this. Security system, you have cameras, okay, and then some controls over here. Then you have IoT control appliances, your fridge is here, your coffee maker is here, your, this is the nowadays we get that broom, no? Okay. So that is there, floor cleaner. Even the lamps you can control, and this is your audio system and everything. So everything is communicating nowadays. And that is only because we are putting in electronics inside it, some intelligence inside it, some smartness inside. So it can give you, it can take some command. This command need not be very complex. It can just be switch on and off also. It can be, if it is a AC thing, we can set the temperatures. If it is a heater, we can set the temperature. So all those things are possible only because of we are making them communicate by adopting IoT, within Industry 4.0. And you can see the protocols over here. Within house, it is mainly wireless. So Zigbee is a protocol that is typically used for building automation. I hope you are aware of Zigbee. So Zigbee is it is similar. It talks. So you can have it hops between device to device. It is a wireless communication. Okay. And this is the center console. This can be on mobile, and you can give commands from here. So from mobile to this station, it can come on GPRS. From GPRS, then the home automation system takes over, and then it communicates with the respective devices, whatever you want to control. So this, and in home, the usage is very pretty less. So it is a very simple solution. But the same solution, if you want to apply to maybe a theater or a big mall, the complexity increases because the volume that we are handling is different. So over here, maybe the AC requirement or the environment requirement will be very simple. It's just one room or two rooms that you have to chill. But when it comes to a very big hotel or this thing, it's very complex to handle. Okay, and this is managed by using building automation solutions. The communication is again over here. It is different. As I was talking about, communication is based on what application you are talking about. It changes with that. So the power we are talking about, ISA 61850, that was a need over there. When it comes to building automation, we are talking about this automation level like LON. It is LON works, then BACnet. So the routers and gateways are designed for that, and that's the protocol which actually it works on. These are LON controllers. We have field bus, which is coming from there. This is LON works. These are protocols. These are protocol. Okay. Okay. These are field level controllers. Field level, they just control the end product or system sensors, whatever is available. So here it is sensors and actuators to switch on off and things. These are fan coils, VAV boxes, room controllers. So everything is getting controlled behind the network. They talk on this very specific protocol, and then that's how it goes up when it comes to the management level, which is nothing but this guy. I'm sorry for that. So this is another distributed digital control, DDC, what way which you call it as. So everything will not come to the center console and then get controlled. So some amount of control level is also given to the individual one. So they can take decision for all these 3, 4, and then communicate the status back. Okay, so that's amount of that helps in prompt action, prompt control action, rather than waiting for. Okay, so this is the information network. This is operation station. This is the engineer station, and this is a typical. I would say it is a network connection that you can see. So this is a control area network. This is a field network. This is field network. So this is available in the area. So this is typically for a factory floor layout. So they will have a based on what kind of activities are being done into that particular shop. Based on that, they will do it. So that becomes a field network. There will be a local controller will be there that will take care of the equipment, products, and everything within that area. So that is nothing but this. So it may have 3, 4, 5, any amounts of systems units attached to it, and then it has a local control, and then it talks to behind. So this is a typical most efficient way of controlling a factory floor. Okay, and And this is possible because everything is, they are like, they can talk to each other. Okay, or they can talk to the unit which they are connected to. For example, this is a small meter, it could be a gas meter, this is a valve. Okay, but it can talk. It can talk and it can get controlled. So it can take instruction on communication bus. Okay, this is again a valve. Okay, so this is not the same typical valve that you would be seeing in earlier. It is not just cock or tap. Okay, so but it talks. Okay, it talks in the sense it communicates. It communicates and it takes instruction on some different through different medium. Okay, like for maybe your basin tap, you have to use a pressure. You have to use a hand and switch it on. But nowadays you are getting something. If you just put your hand inside the basin, the water starts flowing. How is it that possible? There is some electronics behind it. It senses the presence of some object in the open cavity of the basin, and then the moment it sees it, it will start flowing. So this is achieved by using the electronics in a very precise way. Okay, and similar thing is applied to other application areas also. So once we understand what is the requirement in that particular application, then we have to look at which is the kind of electronics that we need to adopt for that particular application and then design. Okay. So one solution in one area may not be the right solution for some other areas. So that has to be always validated before we go forward. So I think I just have maybe a couple of slides now. So where we will talk about exactly what kind of mm, products or technology, electronics technology that you're talking about. Okay. So we were talking about power and energy. Now this is very specific to industrial, as I said earlier. So what in power and energy is that we need to really understand. So we have power in form of AC power, DC power, or it is variable frequency. Converters is nothing but we convert from one form of energy to another form of energy. Okay, so it could be AC to DC. So we have a lot of uh, different ways of converting that energy. And I mean, in terms of usage of electronics. Okay, if the power requirement is very small, we get a small control regulator which we can do that job for you. But as the power requirement goes high, okay, then it becomes more complex. Okay, the classic example is maybe if you have a small project which make use of some small maybe some 10 watt of power, maybe you can use a very small device, maybe I think 7805 or some 7801 7812, some regulator, classic regulators. You can make use of that with a very minimal amount of supporting components. But the same thing, if you want to develop a product which is say 1000 watts, then the equipment, then the chips or electronics that you need to devise, electronics devices that you have to use will be different. The topology will be different. The way in which you make using of electronics, that will be different. Okay. If you go further to that, then you will start facing issues which are linked with that requirement. For example, from low power to high power, the biggest problem is it is flow of electrons. As I said, electronics is nothing but electronics and mechanics. It is flow of electronics. Okay. Now it is flowing something. The electrons are flowing. So it heats up. If the power level is very high, the devices will heat up, the conductors will heat up. So how do you manage that part of it? So that becomes very complex. The classic example is, as I said, one was your lab project or this thing having very low power of maybe 10 watts, 20 watts to that. And let us talk about the current day scenario of electrical vehicles. You will have electrical vehicles which are, I think, maybe 2 kilo or 2.5 kilowatt converters and chargers will be there. And you cannot build something which is huge. It has to be compact. It has to be put on the vehicle. It has to be lightweight because it is going to drive. It is going to mobilize a vehicle on which it is sitting on. So it has to be lightweight, it has to be efficient, it has to be able to handle the heat that is going to get generated. It has to be intelligent because it is going to talk to a lot of other things. And this makes it complex. Okay, and that's what is the crux in solving the problem as an electronics engineer. How can you deliver that? It's still a converter. It's still a converter. You're converting from AC to DC. If I'm talking about an onboard charger for an electrical vehicle, it is still converting an AC power to a DC power. which you would be using it in this thing also, maybe in your small college projects also. But the complexities which around that, it is world difference. Okay, because the scenarios is different and the power that you're handling it is different, and that's what really is the challenge is there. And this is where, if you really understand electronics characteristics of each and every device thoroughly, I don't think there is anything that will stop you from meeting the requirements of any applications. Okay, in power segment. So we are talking about converters, inverters, variable frequency. We have drives which are based on variable frequency. We have PW modulation motors also. We get SMPS switch mode power supplies, linear power supplies, and blah blah, many other things. Okay, it can be vice versa also. DC to AC is also there. That also is. So based on, there are some vehicles which are on AC drives, AC motors. So they store the energy as a DC power, but they have to convert it back to AC so that they can run the motor. Okay, so that's where we use the inverters. Controls. So wherever there is controls, it will be either a digital control or an analog control. Okay, and this behind that. So this is at the end. So we were talking about this local controls. So it will be over here. Behind that, we have this distributed digital control. These controls would be either open loop or feedback loop. Nowadays, everything is feedback loop because it gives you more control on what is it you're going to control. Okay, so that's very important. Now, when we talk about industrial segment, it is we have to move. We have to move from point A to point B. Okay, whether it could be a warehouse or whether it could be a shop floor, you have to move a component or a raw material from point A to point B. It can be done by using maybe a very state-of-art sophisticated pod, which is used in by maybe Amazon or Flipkart's warehouse. Okay, so everything is automated. You don't have people running around fetching the components for you or fetching the product for you. It is fully automated. Okay, and that automation is achieved by using electronics. Okay, so this itself is a big business area. Movement of any item, product, anything from one place to another. If you can do it, now it is intelligent. It can talk to each other. It talks to the adjacent pod also. It also talks to the mainframe. It also talks to the racks which are there available. Okay, so here there is the application of electronics is in huge, and this is going to be future. Okay, all this area which becomes human intensive, the ultimate solution is going to come out in the form of automation. How do we eliminate human beings? So that with human beings, the probability of error is high. The moment we automate it, that goes down. In fact, it is 0.01% or it is 0.01%. It is to that accuracy. Okay, and that's how it is driven. The moment the market talks about certain pain areas, the pain areas you have to understand what exactly is a pain area and which are the critical linkages which is arriving at those bottlenecks or the pain points, and then you can think around how can I make use of electronics, the same RLC and some semiconductor devices to eliminate those bottlenecks, to eliminate those critical paths. Okay, and at then that's how it goes. The industry works that way. You talk about any pain point, somebody would have been working on it days in, day out, and maybe I can give you one example also at the end. Okay, then in industry we're talking about joining something. Either it is two metals or non-metals or polymers. Okay, and how do we achieve that? We achieve it by, if it is metals, we talk about heating the two metals and then fusing them. So which is arc welding or CO2 welding or resistance welding. So in resistance welding, we hold the two metals together. We pass high current through them, and the resistance of the metal, okay, because of that, and when we pass high current, it melts and then it forms a nugget over there. Okay, so different properties of the material that we are going to fuse. Okay, we make use of that, and then we use some apart from electrical or motion, and then we control that through electronics. Electronics always comes in support for two reasons. One is it has to measure something, and the second one is it has to control something, and that's how we really deliver the performance. Okay. So over here also, the objective is to melt to metals, non-metals, or any other thing, and it can be done by several ways. So resistance way is a simple. If you have to join to I would say iron sheets, resistance welding is the best thing, because it doesn't require anything from outside as an additional thing. You just have to pass current, it's done. But when you talk about copper and other thing, it doesn't work like this, because the material itself is it is high conductive of heat. Okay. So for that reason, they will use something else. So it could be arc welding, it could be COT, it could be brazing, what they call it as. They use a very high torch over there. Okay, so CO2 welding is nothing but it is same as arc welding, but they are because by CO2 they're in that entire area they're having only CO2 available, and that actually insulates the spot where you are transferring the heat. Okay, otherwise it will form a different chemical reaction and it will not. Friction welding is something which is used in non-metals very prominently, plastic to plastic welding, any other thing. Ultrasonic welding, it is used for both. It is an excellent thing, because it doesn't do friction in ultrasonic. It doesn't use anything from outside. So you rub two things at a very high frequency, and then the friction it results into slightly that part portion gets melted, and then it fuses with each other. So that's the principle behind it. But how do we achieve this ultrasonic frequency? To achieve that, there is a lot of electronics goes inside it. So we have to shake a tip or something like that at that frequency, ultrasonic frequency. Okay. And that is achieved by using electronics. So there will be some electric components and some electronics component. Okay. Electric is used to convert that motion. Electronics is used to sense and control. So, so the role of electronics is always limited to either sensing or controlling. And based on the complexity and requirement, it will keep on changing. So the sensors will keep on changing, and and the control way in which it is getting controlled, that will get the same, or it has to deliver. In some cases, it also how you deliver it. In frictional welding, it is you have to deliver a very high speed motion. Okay, and how do we achieve that? So we can use some. So there are a lot of this. So and which is given by electrical. Okay, magnetism is used over there. Okay. Another operation is cutting and punching. Okay, so this is the requirement, how we cut a metal and non-metal, and how we achieve it. Because it is industry thing, it is not cutting one sheet metal. People are talking about how we cut maybe 10 sheet metals in one shot. Okay, now this is again, it rolls back to the production requirement. If I'm having a production of 100 units per day, how can I make it maybe 10,000 units per day? Because that's a market requirement, and everybody is working for money. So if you do not meet the customer or the market requirement, somebody else is going to do that, and that's not a good situation for manufacturing or for business. So people will always be thinking on how can I really improve my productivity, and this is how. So they do many things activity at the same time. So instead of cutting one sheet metal with a saw manually, so they will say, okay, let me have a better technology. I will use a laser or a plasma or a water jet to do that job. And in order to use that tool, there needs to be a lot of electronics inside, whether it is plasma, whether it is laser, or whether it is some high-speed saw or punching machine or very high-power punching machine. Everything needs electronics to drive it. It is a feedback system. Again, I'm talking, it is sensors. So if it is we have to sense where we have to really apply your forces. Second one is you have to measure it. It is feedback control system. Afterwards, you have to deliver your output. If it is plasma, you have to release a plasma jet, okay, with that particular power, so that it can really cut those 10 sheets in one shot. If it is laser, the same thing. If it is water jet, it is the same thing. Okay. So actually, electronics is used as enabler to make such things happen. And at the end, electronics is the action, if you look at whether it is a movement, cutting, anything, okay, it is achieved by using some conversion. So conversion in the sense, it could be a magnetic thing or rotary things by using motors, or it could be any other motion. Okay, but at the end we have to use some transducers over there. Okay, and that mostly in our this thing, it is electrical. Either it is using this magnetic principles it is used. Okay. Assembling. So this is another thing. So assembling is we make a lot of components and then we need to put it together to make a product. Okay. Let us assume a small toy, and it has 5 different subcomponents. Okay. This can be done manually. Okay. But if you want to deliver again, maybe 100 toys per day or 100,000 toys per day, that's a challenge. And this can be addressed by using automates. Okay. So I would just advise you to just go on a website, have a look at some automates, how they use. You'll be amazed. You'll be amazed how they're doing it. Okay. And how it and what is the product? What is the soul of this machine? It is nothing but it is electronics. Electronics is driving that huge machine. It is able to drive it. It communicates to the central control station also, and it drives it. It does that job for you. Okay. And okay, the last one talking about this communication. I was okay. Most of the things we already talked about. I think CAN, okay, not CAN. Profibus we talked about, RF, Loanworks, backnet, FlexRay, uh, LAN, optical communication. Okay, so these are specific to certain market segments, certain areas where we actually use it. Okay, then we have this CAN. CAN is an automotive specific protocol. The reason is within okay, and it is an excellent communication channel. Okay, the reason is it is very reliable. Okay, so it is not like RS-232 or this thing where any electrical noise can disturb the data that which is being passed on through that 3 wires or 2 wires. 485 is 2 wires. RS-232 is a 3-wire protocol. Okay, so if that particular channel is going to has to survive in an environment which is having extreme noise. Okay, like for example, when we talk about automotive, we have engine is radiating a lot of electromagnetic noise. And if you have electronics, this is the vulnerable thing associated with electronics. It gets very quickly impacted because of electrical noise. Okay, and as a designer, let it be any segment. As a designer, you should first understand what is electronics or noise level in which my product is going to survive. If you understand that, then you will understand also what are the measures that I need to take care of in my design so that it will survive in that. Okay, a lot of standards are available around it, and it is all based on which segment we are talking about, market segment we are talking about. We have separate standards for power energy. There is separate standards are available there because there is the noise signature is different over there. In automotive, the signature are different. Okay, when we start a vehicle, there is a typical noise signature is there, which you call it as a load dump test and the load dump and all those things. Because most of the loads which are available on the vehicle, they are either inductive, mostly inductive, and inductive has a certain way of working, functioning. Okay, and that results into all those noise. Okay, and that also will be cause for a lot of failures on your product. Okay, so before we design any product, okay, so before we design any product, we should be very thorough with the environment in which your product is going to work on. Okay, once you understand that, then you will understand what is the level of robustness that I have to build into my product. Whether it is medical is that way very safest because it is inside the very, at least it doesn't have to face anything on thermal front. Okay, but if you talk about something like defense, and that's the reason the defense requirements are very high, very stringent. They are very high as compared to the commercial ones. It has to face extreme climate conditions, very high temperatures, very high humidity, very high within humidity there is also salt. Okay, in some cases that even the salt corrosion is there. So we have to develop a product which will survive into that harsh environment. Okay, so before you start putting even one active or passive component on your design sheet, first thing you should understand it, what is the environment around of this product which you are planning to design. What is the requirement? What we are talking about, always there is a difference in what is the quantity. It makes huge amount of difference. Designing a power supply of a very small wattage and designing something which is of very high kilowattage, is a huge difference. It is a world of difference. Designing onboard charger for an electrical vehicle is extreme. It is challenging. It is challenging because the amount of power that we are going to handle. Another thing is we don't have time. Okay, we cannot take our own time to charge the device. Okay, because the customer expectation is how can I charge my vehicle in a very short duration? It could be 15 minutes, 30 minutes, 1 hour, 4 hours. And everything has a lot of dependency on electronics because electronics is the only thing which is between these two to make it happen. Okay, and it is not something, it is not a heavenly thing. It has its own limitations because we are talking about flow of electrons from either wires through devices or through fiber thing. Okay, so these are all conductors. Conductors has their own properties. They heat up when there is the amount of energy that they're handling is uh, it is of a high level. So as a designer, first thing is you need to understand these things. Okay. Otherwise, it once you understand that and then you understand how you can solve those problems. Okay, or how you can address those problems proactively in your design. I think your success rate will be very high. Okay, and that's only is the differential factor. The only reason why people want to move from now this I'm talking more from electronics point of view, from hardware point of view. Hardware means we are talking about RLC, resistor, capacitor, inductor, and semiconductor. I'm talking from that point of view. There is whole different segment which is there, which is called as embedded software or software part. Even if it has to be that way, even if you want to get into a career which is into electronic software, embedded software, still it is very important for you to understand how the hardware works. Okay, and that is going to decide your reliability of the software. That's how it will work. Okay, in sometimes because certain limitations which are there in hardware, they can be addressed by using some additional features on the software. So it goes in hand. It is embedded always. Okay, there will always be some limitation either in the software side or the hardware side. But overall, when we put it as a package, it is electronics. It is embedded product. It is electronics product. Okay, so you should also know as an engineer, don't differentiate between hardware and software. Nowadays, that is a big. I think it's a big issue with the people, with the young students. Don't never classify yourself as a only software engineer. People think that is the safest thing. It is safest thing for some time, but if you are unable to deliver the product, it is a failure. Okay, so it is very important for you to understand if you are controlling any electronics, how my electronics is going to respond to it. Okay, because software is going to run at a very high speed. If I'm talking about microcontrollers, most of the industry, I think they work at a very. If we leave the consumer electronics aside, most of the things can be taken care by maybe even a microcontroller which are available maybe 7-8 years back or even 10 years back, I would say, because the requirement is not on processing power, it is based on the reliability, okay, and the power consumption. Okay, so these are the two things which drives it. Okay, so even if it is maybe a microcontroller operating at maybe 10 megahertz or 20 megahertz, still it is sufficient, it has a lot of processing power. The best thing is how you write the software and hardware, and as a combined, you make it a very efficient and effective thing to deliver the end function. That is very important. Okay, so as an electronics engineer or this thing, never get isolated from the physical things. Okay, even if it's software, unless and until you have to get into an application programming. I'm not talking about that. Application program is completely different. It is about what this is software. Maybe the languages you might still use the same. It could be C, C++, but the stuff is different. It is application area is completely different. I'm talking about the low-level softwares. Okay, the drivers that actually, even if I'm talking from a laptop. My laptop has a high-level business software, but below it is having an assembly coded program, which we call it as BIOS. Okay, basic IO instruction set. So that is written. That is what goes into embedded software. Okay, so if you talk about any gadget around you or a system around you, let's talk on. So it has the embedded software inside it, and that along with the hardware if you don't understand how we are going to complement each other, then the effectiveness of the product that you're going to design, it is not going to be really that impactful. Okay. So I think that was my last slide. Oh, I think we lasted for 2 hours. That was so. Thank you all. Thank you, Gates Institute, for giving me this opportunity to talk about something on electronics. Sorry, I was unable to make content which I think it was from my side. I was unable to get in touch with the professors and other thing to get aligned. Maybe that could have been much better session. I'm not sure. Maybe you can give me a feedback. If anybody has a question or something, maybe I think we have 5 minutes to go, madam.
Yeah, sir. We will wait for 2 to 3 minutes because there's a delay between the Zoom and the YouTube. It takes 2 to 3 minutes.
Gotcha. Okay.
Okay.
Betty, shall I ask a question? I am Professor Manan.
Yeah, sir.
I will
Sure.
introduce
Go on.
Yeah.
Professor Ratnadeep. It is from the point of view of students as well as our faculty staff members.
Yeah.
It is how to get into the industry is the biggest problem we are facing. The students are also eager to get into this core industries, but they don't come to know how to prepare themselves for getting into. Is there any bridge course or some short-term courses which will prepare them better for industry? Because we hardly study 1 or 2 subjects pertaining to industrial electronics, really. So, is there any bridge course or a preparatory course for applying for certain industries or certain core industries? Because we don't come to know the direct admission or direct trainee management trainees and executive trainees announcement we hardly ever come across. That is my question.
I think this is a very good question. This is exactly what I started with. We get into academies, we get into college, but we don't know how to get into industry. First of all, we don't know what industry is available for us. So,
yeah.
And this was my pain point when I was doing it. And today also the problem still remains. And I also said there's a big gap between what the industry expectations are and what the students which are coming out, what they are prepared for. Okay, and that gap actually is it is quite wide. Okay, so some, like even I was there with the organization, and we were trying to bridge this gap by coming closer to institutes. Okay, so that's the only way which will help to bridge us these gaps. Okay, if you talk about additional courses and other thing, yes, we can. There are some institute which actually helps, but what they do is they will just take the today's problem. Okay, so whatever I've been talking about, they will take something which is very latest. Let us say IoT. So IoT is one of the areas. So they will take this as a project, put some 4-5 people on it, and they will drive that program for maybe 3 months or 6 months, and they will have an application associated around it. So if it's say IoT, then they will say, let us have one communication channel, one electronics board. They can use any ARM board or something like that, and some application which is built around it, which can be anything. We can just think about any, because I have given a lot of big view of what are the application available around you. Okay, just have a look at it and we can think of an application, but this is still a very limited way, I would say. So one good thing is giving student exposure of the industry is very essential. Okay, either we have to bring the industry inside the campus, okay, or we have to have some additional courses apart from whatever is there in curriculum, so that they get exposure on how to work on real life problem which are available there in the industry as of today. Okay, so if you're talking about electronics, then the focus should be on, I was talking about this issues around the environment of the product, which is EMI, EMC, industrial standards. I think if people are ready with that and they talk to their the possible recruiter in the same language, then I think the probability of people getting absorbed is very high. Okay, because the standards another thing. It is an industry part. That's how we are looking at it. And as an academic, we have to only look at only textbooks which talks about the basic stuffs. Okay, but over and above that, if we can give an exposure to these people for working into such areas, okay, I'm going to talk about electronics. So identify an application which people can take as a product. It need not be solved only by the final year student. It can be one product, one program, which is huge one. We have people right from second year till fourth year. We can have different teams and everybody comes and contributes. So that creates a system for everybody to learn and understand. Okay. And the best way to learn is, I think, more than classroom teaching, it is doing it, it is learning by empirical way. Do it by your own hands, make hands dirty, then that's the best learning. And that will remain for you for lifelong. So get something which is today's pain point, today's industry's pain point. You can identify anything. You can go around institutes or, sorry, not institutes, industries around Hyderabad. Talk to them, like what are the pain points that you can see? Maybe some of them even I can share with you. But go with those pain points, get some people attached to it around industry, because we need a ecosystem around it. Okay. So and if you drive such kind of thing, I think that would help. That would help. And I have seen many institutes doing that. I can give you example of myself. I had set up a laboratory in Vellore Institute, VIT, full-fledged laboratory over there, and where student can go do industrial projects over there. We were giving some industrial advice to them. Industrial problem statements were coming from them. Okay, so if you start getting this industrial problem to start with, that also will be a lot. If you have your own laboratory inside your college, get industry problems. Okay, just talk to some industry experts and ask them what are the problems that you have in today. Okay, ask your people to work on in a big team that I was talking about, third, second year to fourth year. They can collect it along with the professors, of course. Okay, professors and some. If you can get some industry expert also along with them, that will be really nice. Okay, if people start working on today's problem, they can start correlating things around the world around them. The main problem is we have the education is the industry looks for people who can solve that today's problem. Okay, and that's how they look at it. Okay, and another problem with industry is the competition is so tough nowadays. Okay, everything is it is run as a business. Okay, and so there is a lot of cost attached to it, money attached to it, time attached to it. Okay, so it is better to partnership with some industry around which is close to you. That will be easier. Okay, and that will help the people. Have some industry visit, take some problem from the industry. I think that could be that could be a possible solution. Okay, and I have seen many educational institute doing that. Okay, you can also have a look at the CDAC courses, what they're doing. I think either they can get you can loop your institute with CDAC, or you can bring similar kind of courses in your college, professional courses. That also will help make them industry ready. In short, I would say, how can you make people industry ready? I think that's a situation will change. Then industry will come running behind you. It is easier to say, but it is a huge amount of work. Okay. So I was also involved into this for B2B from my journey with Tatas and this thing, but it is a huge thing to do. So that's what I would like to say, Mr. Manan.
Thank you.
So we had a similar question like this, but the participant has added one more thing, like internships for the students, like anything like that.
Sorry, please come in the chips.
Internships from the industry.
Internships. Yeah, internship is that many of the industry, they encourage internship. But as I said, no, internship, some colleges, they have it, some industries, they give it free of cost. So it has to be at the candidate's expense. And some industry which are doing well, they also pay some small amount of monetary benefits also they give. So that comes as a handy. But the intake is limited for industry. From industry to industry, the intake is limited. Okay, and yes, I think industry is opening up for that kind of proposals from the industry. It's a good thing. I think actually, when students get into fourth year, no, right from beginning, you can have some. There can be an agreement between the industry, like he's an intern, and for entire 1 year, we can have some 1 day or a couple of days working in the industry. So they can go to the industry, take the problem statement, come back along with the professors. They can work again, go back. So that arrangement can be done. Okay. Because industry to industry, it keeps on changing. Some industry people want them to come full time. Some people want to take, say, once in a while, once in a week, twice in a week, based on what is their situation. If they have really a critical problem to solve, then they would like to have these people stationed in around the factory and come every day. That also is there. So more than industry, get attached to design houses. That will really help. It's a very good thing to encourage this internship. It's required.
Sure, sir. So that's the end of the question part. And they said that the session was interesting and the session was good, sir. Participants.
Thank you. Thanks.
Can we finish the session, sir?
Yeah. From my side, yes.
Okay, sir. 1 second, sir. Now, I request the convener of this faculty development program and head of the department, Mr. M. Imtiaz Pasha, sir, to give the vote of thanks for today's speaker.
A very good afternoon to one and all. It gives me an immense pleasure to deliver the vote of thanks for today's session. On behalf of Gates Institute of Technology and Department of Electronics and Communication Engineering, we wholeheartedly thank the today's speaker, Ratnadeep Pingale Garu, for giving valuable insights on different segments where electronics are used, like medical science, transportation, defense, etc., and also giving us and letting us know the bridge, the complete picture between electronics and industry, and by widening the view of electronics in different applications and in different sectors. Thank you, sir. Thank you very much, sir.
Thanks, sir. My pleasure. Okay.
And now, thanks for all the participants for contributing your valuable time and presence in today's FDP. And as usual, we will be meeting for the day 5 session tomorrow at 11 a.m. to 1 p.m. Thank you. Thank you all.